Agenda. In this short video, I'll discuss the following topics. Topic number 1, Introduction to two functions. The first one is called interactive merging. So we have two data sets, how to merge them. Function 2, from monthly exchange rate to quarterly. I'm going to use these two functions for other topics. Topic number 2, how to calculate correlation between two exchange rates. Topic number 3, definition of VaR, value added risk, and its related formulas. Topic number 4, one example, calculating VaR. How to calculate the maximum loss in 3 months for 5 million Canadian dollar receivable with a 99% confidence interval. Topic number 1. I'm going to discuss two functions. Okay. So type .get data. Okay. And so there are two functions. The first one is called interactive merging. Okay, so shortcut is .im. The second one is for exchange rate, monthly to quarterly. So let's look at the first one. So you simply type .m. So if you type function name, it will show you the meaning of the function. Okay, merge two data sets, then copy to Excel. So we copy data set 1, we copy data set 2, then we paste back to Excel on Notepad. Okay, assume we have two data sets. I'm going to use this one. So this is data set 1. So this is data set number 2. Okay, we have two data sets, and we are going to merge them. Okay, and so let's do it. Okay, so let's type IM, left, right, parentheses. Okay, so objective merge two data sets by a common variable. Okay, and we have two data sets. The date is a common variable. We are going to merge these two data sets based on the date. Okay, so hit the enter key to continue. So hit the enter key, and if we have a data set, we can copy this one. Okay, so let's copy this one. Copy. So if we have Excel, we can copy there. Okay, then hit enter. Then we copy it second time. Then we hit enter. Okay, then we launch Excel, and we can paste it there. So this is our final result. Okay, so this is function 1. Okay, so let's look at the function number 2. Okay, so let's go back to R. Okay, so .get data. So this is exchange M to Q. So monthly data to quarterly data. Okay, we download the monthly data. We copy the data. Then we issue this command. Then we paste it back. Okay, so let's do it for the exchange rate between Canadian dollar and US. Okay, so let's this is Canada US foreign exchange rate. Okay, this is Canadian dollar to 1 US dollar. So this is indirect quote. Okay, so click max. So let's download. So let's download the CSV file. Okay, so this is a data set. Okay, and data set is January. It's monthly. Okay, January, February, March. Okay, so we are going to pick up this observation, and this observation, and this observation, and continue this way. The function monthly to quarterly behave this way. So every March, June, September, December. Okay, so we Control Shift down, then we copy. Okay, then we just click dot exchanger M to Q, left, right. Okay, copy your data, then hit enter. Okay, go back. I'll show you again. So we copy our data, then we go back to R, hit enter. Now to Excel and paste. So we go back to Excel, then we paste it anywhere. Okay. Now you will see, so this is this value here, June, September, December, March, June, September, December. Okay, so this we convert monthly data to quarterly, because when we calculate VaR, we need quarterly exchange rate. So we need exchange rate. Topic number 2. So what is the correlation between percentage of two exchange rate? Okay, .ICE 11. Okay. So objective. Okay. We know that for portfolio risk, the correlation between security, underlying security, plays a bigger role. Okay, the lower the correlation, the higher the effect of diversification. Okay, and for this exercise, we download the Canadian dollars versus US dollar and British pound versus US dollar. Okay, we are going to calculate correlation between two exchange rates. Okay, and manually we can download these two exchange rates. Okay, and if you access my code, interactive merging, then you can save some time. Otherwise, you can download this merged dataset here. Okay, I'm going to show you how to merge it. So just copy and paste the browser. Okay, so I have just pasted it here. So this is Canada, US foreign exchange rate. Okay, so look at the unit. If this is Canadian dollar to 1 US dollar, so this is indirect quote. We're going to convert into direct quote. Okay, click max, then download. So this is a CSV file. It's opened. So this is our dataset. Okay, this is first exchange rate between Canadian dollar and US dollar. Okay, so let's look at the second one. Second one is British pound and US dollars. Okay, so paste it here, and so this is US UK foreign exchange rate. Okay, so if you look at the unit, US dollar to 1 British pound. Okay, so this is direct quote. Okay, we don't have to convert this one. Just click download. I click save file. Okay, so we have two data sets. Okay, so let's copy the first one. Okay, so go back to here, type .im. Okay, hit enter. Okay, copy dataset 1, then hit enter key. Okay, let's go back to Excel. So this is, so we click Control Shift down. Okay, we copy, we go back to R, we hit enter. Step 3, copy dataset number 2. Okay, so we go back to the second exchange rate. So we highlight, Control Shift down arrow. Then we click copy. Then we go back to R, we hit again. Step 4, paste the merged data to Excel. So let's go back to Excel. Okay, we randomly pick up. So let's paste it here. Okay, so this is merged. Okay, so if you look at, so this is January 1971. It's consistent with number here. Okay, so if you go back to the pound, so this is starting date 1791. Okay, very, very early. Okay, okay, so we are working on this data set. Okay, again, so this is a direct quote. You see the Canada first, US dollar second, the US dollar first, and UK later. Okay, so this is direct CN, so US versus CND. Okay, US dollars for 1 Canadian dollars. Okay, so equal 1 over indirect quote. Okay, so this is indirect quote, this is direct quote. So it's a good idea we convert to be consistent. To be consistent, so we convert indirect quote to direct quote. Okay, okay. So next one, we calculate percentage change. So this is percentage change. For the UK equals, and as I mentioned before, and we can use this value minus this value, parentheses, divide by this value. Okay. Alternatively, we can use, okay, I'll repeat, okay. So this value minus this value. Okay, close it, divide by this one. Okay, so this is about 6%. Okay. Alternatively, we can use this value, divide by previous value, then minus 1. We have the exact same result. I'm going to use formula. Okay, okay, so this is I3. So I3. Okay, so G3 divided by G2 minus 1. Okay, the previous formula is G3 minus G2 parentheses divided by G2. Okay, and the difference divided by G2 is easy to understand. However, so this formula is less likely we make a mistake. Many students will difficult parentheses. So this is percentage of the US UK. This is US UK. Okay, so this is percentage change US CND. Okay, percentage Canada. Okay, then we can simply copy and paste. Okay, so this is H3. So this is H3 divided by H2 and minus 1. We can paste. Okay, so what is the correlation? So correlation, we can simply use Excel CORREL. Okay, return the correlation coefficient between two data sets. Okay, so this is, we can I column, comma, and J column. Okay, I'm going to show formula. Show the formula of this. Okay, the correlation between two exchange rates is around 58%. Okay, of course we can use the, we can highlight. Okay, highlight, Control Shift down arrow. Then we enter comma. Okay, then we highlight several rows, Control Shift up arrow. Then we close it. Okay, we will have the same result. Okay, when we can use this I to I column with nothing below our data set or nothing above our data set. Then we can choose the whole columns. Okay, this is end of topic number 2.
Shutterstock Music.
Let's discuss the topic number 4. So type .ice. Okay. Topic number 4 is calculate value at risk for foreign exchange rate exposure. Okay. So this is 13. Okay, so this is assume we have 5 million in Canadian dollars receivable outstanding. What is the maximum loss in 3 months, 1 quarter, with a 99% confidence interval? So actually, we can also claim what is 1% chance in 3 months. What is the maximum loss? Okay, and so let's get the data. Okay, so let's get the data. Okay, I'm going to copy this instruction. Okay, copy instruction to our spreadsheet. Okay. Okay, so this is our position. It's 5 million. 1, 2, 3, 4, 5, 6. So this is our position. Okay, I'm going to make it a bit bigger. Okay, 5 million. Okay, and alpha is 1%. Okay, confidence interval or confidence level is 1 minus alpha. Okay, 1 minus alpha. Okay, and I'm going to insert another 2 columns here because I'm going to copy data here. Okay, okay, so let's get the data. Okay, so this is we go to this Canadian US dollar exchange rate. Okay, so yeah, this is location. So let's do it one more time. So we click max, then we just download. Okay, I'm going to copy, Control Shift down. Okay, so I copy. Okay, because we are interested in the quarterly. Okay, so dot exchange monthly to quarter. Okay, type exchange monthly to quarter. Okay, copy your data, then hit enter. Okay, I do it one more time. So just copy, go back to R, just enter. Then I'll go back to my Excel. Okay, I paste it here. Okay, so this is my, okay, I insert another column. Okay, so this is March, June, September, December. So the frequency is quarterly. Okay, so this is 1 quarter. Okay, okay, I'm going to copy the formula as well. Okay, formula. Okay. Okay, the formula VaR is our position time expect percentage change. If we don't have expectation, then we can use mean minus the z. Z depend on the confidence interval, okay, confidence level and standard deviation, okay. And first one is because this is as I mentioned before, it's always good idea to use direct. Okay, so this is, we convert indirect to direct. So direct quotation. Okay, then we calculate mean, we calculate standard deviation. We have to calculate percentage change. So this is not correct. So this is percentage change. Okay, percentage change will be this quarter divided by previous quarter minus 1. Okay, so this is percentage change. So that is from 99 to 97 is negative. Okay, so this is percentage change. Okay, I insert one column here, and okay, so this is percentage change. Okay, so mean is average. So average of the columns. Okay, so this is percentage change. I'm going to show the formula. Okay, so this is percentage change. Okay, then the standard deviation, STDEV, standard deviation of percentage change. Okay, so Z value. So Z value is simply equals norm S inverse so probability. So probability, so we use confidence interval, and this is 2.32. Okay, and so we have position is 5 million and percent. So if we know expect percentage change, we can enter here. If we don't, then we can use our mean. Okay, minus Z value 2.32, and standard deviation. Finally, our VaR. Okay, value at risk equals our position times our mean minus our Z value times standard deviation. Okay, so I'm going to show the formula. Okay, the formula is exact according to this formula. Okay, position is G2 5 million, expect value. If we don't have expect percentage, we use the mean. Okay, minus Z value. When the alpha is 1%, confidence is 99%, Z value is 2.32, and standard deviation of percentage change is 0.029. Okay, so the meaning of this one is we have 5 million receivable in Canadian dollar. Okay, we have 1% chance. Okay, so we have 1% chance to lose this amount. Okay, we have 1% chance to lose 345,356. So this is value at risk.
Shutterstock Music.